Hello. So, in this example, we want to use linear approximation to get an approximate value for a number. So, remember, the whole idea of a linear approximation is really just using a tangent line. So, in fact, when I see problems like this, I sort of don't even think about linear approximation itself. I just think tangent line, right? When I read this, I'm like, okay, use linear approximation on the function f of x. So we have f of x is x square root of x. For x equals 9, that's the sort of easy to calculate point, to approximate square root of 10. But square root of 10 means really I'm approximating f of 10, right? So when I read this, what I'm really thinking in my head is find the line tangent to f of x equals square root of x at x equals 9, and then evaluate at x equals 10, because that's really all I'm doing here, right? So that's what I'm going to do. So I'm going to look at f of x is square root of x. Okay, so I want the tangent line at x equals 9. All right, so I need the slope and a point. So I can find the point, right, by doing 9 comma f of 9, which is 9 comma square root of 9, which is 9 comma 3, right? So that's my point. And then I need the slope, m, but the slope at the point is just f prime at that point. So f prime, right, if I'm thinking about f prime of x, that's taking the derivative. So I'm going to have 1 over 2 root x, right? So this is taking x to the 1/2, and then I drop the 1/2, and then I do the 1/2 minus 1, which is 1/2 x minus 1/2, or 1/2 times 1 over x to the 1/2. X to the 1/2 is again square root of x. The 2 is still on the bottom, so I get this. So in particular, f prime of 9 is going to be 1 over 2 root 9, which is 1 over 2 times 3, or 1/6, right? So I got my m, I got my point, so my tangent line. So my m is 1/6, my point is there. So my tangent line is going to be f of x. Well, I shouldn't use f again, so let's make it L of x for the linear approximation, even though we're really just thinking of this as tangent line. L of x, so this is going to be m 1/6 times x minus x1 plus y1. Okay, so there's my tangent line formula. And then I want to evaluate at 10. All right, well, my L of 10 then is 1/6 times 10 minus 9 plus 3, which is 1/6 times 1 plus 3, which is 3 1/6, or 19/6, or 3.16, where the 6 is repeating. So I guess that's actually not approximately, that is legitimately equal. Although calling equality with a repeating decimal is a little shifty, but that's fine. So my approximation then for square root of 10 is 3.1666666, etc. Okay, I would actually opt for the proper form, but you know, depending on your application, I guess. Okay, so that's really it. Doing a linear approximation is just find the tangent line, right? Find m, find the point, build the line formula, and then calculate, and we're good. All right, so that's that. Hello. So in this example, we are using linear approximation for the cube root of x, where x is 8, so that's going to be the easy to calculate part. And then we want to evaluate at 7. So again, when I see this, right, I'm not really thinking linear approximation, I'm thinking tangent line formula, right? So what this is saying is I want to calculate the tangent line of the cube root of x, which I'm really going to write as x to the 1/3, at x equals 8, and then evaluate at x equals 7. Okay. All right. So, right, I need a point and I need a slope. So the point is going to be, right, I'm given where, so I want 8 comma f of 8, which is really 8 comma 8 to the 1/3, which is really 8 comma 2, right? Cube root of 8 is 2. Then I need my slope, so m is going to be f prime at the point 8, and in particular f prime of x, right, is going to be the derivative of this, so I'm going to get 1/3 times x to the 1/3 minus 1, so that's going to be 1/3 x to the minus 2/3, which is going to be 1 over, so I can put this in the bottom, so I'm going to get 3. This is the cube root, the 3 on the bottom, of x squared. So this is going to be the cube root of x squared. So in particular then, f prime of 8 is going to be 1 over 3 times the cube root of 8 squared. And the good news is I can do the cube root and the square in whichever order I want. So in particular, I'm going to do the cube root first, because that's just 2, then squared. So I'm going to get 1 over 3 times 2 squared, which is 1/12. Okay? So then my tangent line formula, which I'm going to write as L of x, is the slope, 1/12, times x minus x1, that's the 8, plus y1, the 2. And then I want to evaluate at 7, so L of 7 is 1/12 times 7 minus 8 plus 2. And this is nice because it's going to account for the fact that I should have something smaller than 2, right? If my cube root of 8 is 2 and I'm looking at 7, I should have something smaller than that, right? Because 7 is smaller than 8. But that's going to get accounted for with this negative right here. So this is 1/12 times -1 plus 2, which is 2 minus 1/12, or 23 over 12, or whatever that is, 1.9 something, 8, I don't know, whatever it is, 983 repeating or something like that. I'm going to leave it as 23/12. So that's, I mean, this is it. So using linear approximation, which means finding the tangent line, I wanted it starting with x equals 8, so I used 8 to get the point 8 comma 2, because we're looking at cube root. Then used the derivative and evaluated 8, so I figured out the general derivative, plugged in 8, which, using this trick that I can do the power and the root in either order to do it easier, so that I did the root first to get 2, then square that, 4 times 3 gave me 1/12, and that's m, x minus the x value I got, plus the y value, and then calculated 7, and I'm good. So that's that.